Hello, I would like to welcome you again to this fourth video on the series of crash course on Python. I will continue from where we stopped in the last video. In the last video, I was actually trying to verify whether the actual dropping of or removal of components from a list was successful, as when we checked the component which we dropped or removed was actually not in the list, which was done successfully. And so far what we have been doing, we have been working with one-dimensional lists. Now I am actually going to start by talking about the two-dimensional lists. And as you can see in cell 1 here, what I have created a two-dimensional matrix using lists. And as you can see, now I have a list within a list. This is the original list where we have this square bracket starting there and ending there. And then within the list, I have a set of lists also. Therefore, we call this nested list, where we have lists within lists. Okay, so can you see they are separated, the components again, even though they are lists, they are separated by comma. Just in exactly the same way as the individual components within the lists are also separated by commas. So it's very simple, very easy to create. So if I run this list here, it should actually give me the matrix. And as you can see, it actually just displayed it for me as one row. And then it tells me the element at row 1, column 2. It will actually tell me what I want here to print. And what I'm trying to access is row 1, and I want element 1. And element 1 is this element here. Therefore, it actually goes, once this executed, it will actually just select that element which sitting in row 1, element 2. Okay, so it's, sorry, element 1, which is actually a 2. That's what I have selected in this statement. Now, creating lists of lists. Now, that means I can actually enter in my list anything that I want, data type wise. As you can see, I entered the string and followed by a number of integers. And the first one is a name for Alice, a name for a name for John, a name for Alice, and a name for Bob. And it's followed by some integers. And these integers, I intended for them to represent some scores for some subjects that this student have taken. And then I wanted to access a single element within a row. So I will use grade, which is the name of my list, and then I will send the coordinates of the list and the component that I want to access. And in this case, I wanted to access grade at row 1, which is this row here, because that's row 0, this is row 1, and this is row 2. And then I wanted component 2, which means it's this component here, because that's component 0, component 1, and component 2. So by entering this 2 here, I am trying to access this. If I change this to 3, sorry, let me run this first so you can see. Okay, now if I change this to 3 and run it, it should give me 89. Okay, so it's actually saying row 1, and I want the second component, which is this component here, keeping in mind that we start at 0. So this is how it actually works. So it's so simple, common sense. If you know the actual rows and columns, you should be able to access individual components as you want for that component only, which can be very powerful when you are dealing with some later on with some highly complicated codes when we build some machine learning algorithm, or if you are actually working with some data science data. Okay, so what if I want to add element to nested lists? Well, let's try. If I want to add, that means I need to call the function append. Okay, and how do I call the function? You remember we created a matrix here, and now I just want to append to this matrix a component. So I select the row at which I want to append the component, then I will call the function append, and I will pass to it the component I want to add. And this will add the 10 to the end of the first row, because again, I just repeat that we start at index 0. So once I've done that, I can print. And then I can say I want to access the second matrix which we have created, which is grade. And I wanted to go to row 2, and I wanted to access component 1 in row 2. So that's the first thing I have done in this piece of code. Then I wanted to replace a grade in row 2, component 1, and I want to make it 85. So let's go to component 2, which is row 2, component 1. What is it? Row 2, component 1 is 78. So if I come to change it, I want to change it to 85. Therefore, if I print that, it should be 85 rather than 78. So let's run these three statements here and see what happens. And as you can see, now it has actually given me the matrix. First of all, the matrix with the appended 10, which is this 10. These are the three original components in that list, and this is the appended component. Okay, now I wanted to access the grade. It was 78. Then I wanted to upgrade this grade to 85. It's upgraded, and I used this command here to upgrade it, where I actually changed the value, the individual value. Remember this, because later on when we come to create tulips and we try to do that, tuples, and we try to do that, we will not be able to do it, because tuple is an immune list. It doesn't allow us to actually change any variables in that tuple because of security and protection of data. Because in some cases, when you are given data, you want to manipulate that data, but you don't want to change that data. Therefore, you actually bring it as a tuple in that case. And if you want to change part of that data, you assign that part to a list, and then you manipulate that list. And the only thing that changed during your manipulation is the list. The original data which came as a tuple, it will stay the same as it is, because you want to protect and preserve that data. Okay, so the last one is actually changing the grade. So we changed the grade and then we displayed it, and you can see now instead of 78, it has actually changed to 85. So this is how simple it is to manipulate these lists. Okay, the next thing, I want to take that matrix, and instead of having three nested lists in the list, I want to make it into a flat list, a flat set. So I want to iterate on each of the rows and read the content of that row, and then just write it in a new list, and we call that a flattened list. So what do I use for that? I used and I want to pass the number, but I want to actually read row by row and then read number by number within that content of that row, and each element I read, I will actually assign to the new list, as you can see here. So it's very simple for loop. It's nothing complicated there. And I'm just saying that the flattened matrix is equal to num for row in matrix, which is the matrix created here. Okay, and then I say for number in row. So I am actually entering into the row, and then I am actually again using a for loop to iterate over the numbers within the row itself. So I will go in the first index, second index, and third index in each row, and I will write the content into my flattened uh, list. So let's see if it works. If we run this, as you can see, it works. So it's just a simple for loop. I went into the first into row index 0, then I went into the content of that nested list in that row, and I iterated over index 0, 1, 2, and 3, and then I end up at the last component in that list. Then I will get out, I will go back in the loop, I will increment the row number. It was at 0, now it will be row 1, and then I will iterate again at the content of that row. I will go to index 0, 1, and 2, and then again I will increase the row number to row 3, and so on, and I will continue until I finish reading all the components in all the rows. And this is how it's done. Now, to be able to actually understand this better, and I keep repeating, please create a new customized array by yourself, and then execute this loop to create a flattened list rather than a nested list from it. It's an important issue because you might have to do this many times, and you need to understand how to do it, because it might sound complicated, this actual for loop. It's a nested for loop. It's 4 within 4, and it's easy to actually understand it, because in C you used to write for, and then you put I equals 0, comma, I is less than or equal or greater than 5, 6, and then comma, I plus plus, and then once you've done that, you go and you write for, and then you put your second for loop, which is like this, and you execute it. And this loop here is no different. It's saying for row, which is the row in the list, and we have two rows, 0, 1, and 2, because there's only 3 rows in that nested list. And within that, we have to increment for each end of each row, we have to increment the row number. And within that, we have another for loop, which is the second for loop. And in there, I iterate over the number in the individual row. So this is how it's actually done. So I will remove that, and you have it there. And if you have any questions, please post a message and I will reply to you. Now, iterating through nested list, and I said for row in matrix, for number in row, print num and actually just want to put the end is equal to 0. This actually moves the next line for the next row. So this is what I have done. I actually just repeated the same thing, but I used a print statement to remove to actually stop and have a return at the end of each row. So I've just repeated the actual for loop which I have here. I actually repeated it here. Okay, so if I run this, you can see now I come to the end of the first row, then I actually have nothing, then I can iterate and I can go and print. I print there at the end, then I go to the second row, I increment the row number, row index, and then I go and write, and when I finish, I just again enter space, and then again I go to the third row. So I can have it flattened, or I can actually have it as an array displayed. But Remember, I don't have the actual brackets around it. Okay, a three-dimensional nested matrix, and which is a nested list, where you remember again, this is the first close bracket and this is the last close bracket, and then I have two nested lists, which is this is the first open bracket for it and this is the closed bracket for it, and this is the comma separating the first nested list and the second nested list. And in the first nested list I have two lists. This is the first list and this is the second list in the first component in that nested list, and this is the first and the second in the second component of that nested list. So this will give me now a three-dimensional matrix. Okay, so let's try and run this. And what do I have? I tried to actually access row 0, component 1, which is this component, this component here, because that's component 0 and this is component 1, and I want to access component 2, and in this case it should actually give me, I'm talking about row 0, and I want component 1, which is this one here, and then I wanted component 1 is this one here, because that's 0, that's 1, and I wanted 2. I have 0, 1, and 2, so I'm actually trying to access this variable here, which is 6. So if I run this, it should give me 6. Now, if I change this into 0, it should actually give me 4. And if I change this into 1, then I am actually working in here, and then I'm going to 1 and 0 should give me 10. So it'll give me 10, and if I change that into 0, and I change that into 2, it should give me 9. Sorry, it's 0, no, it should give me 6 because I brought it back, but if I keep that at 1, sorry, then I'm working here and change that to 0, then it should give me 9. That means I access this list and the first component of this nested list, and then I ask for this, which is number 2, and it should give me that. So element at layer 1, row 0, and let's bring that back to 0, 1, and 2. And that brings us back to what we started with at the beginning of this exercise. Now, next, I want to create dictionaries. And to create dictionaries is very simple. We know how to create lists. We know how to create nested lists. And this is exactly what we are doing here. But in dictionary, we will create it using these curly brackets. Now, again, it can be any type of data, but in dictionary, we start with a key, okay? And then we assign a value to this key. So in the first line or row, if you like, I have created a key called name, and then I assigned to that key the name John. Then I said the second key is actually age, and I assigned to that key 30, and then I looked at the city for an address, and I said this guy lives in New York. Now notice that I have mixed in this dictionary the actual variables type. I have text and I have integers. I can also have floats. I can, put Boolean. So it can be any type of data that you can think of. And in the list, you can actually see we have separated them by comma, as you can see. So if I run this, it should actually tell me that name, John, age, and city. And don't forget the name of the dictionary is person. So if I run this, it actually gives me the content of that dictionary, which is name is John, age is 30, and the city in New York. Now, whatever we applied on the previous lists, we should be able to apply in the same method to the dictionary. So if I go and try to access this, then I would print name, and this is the key that I am trying to access, and then I will call the dictionary person, and then I will pass to that the component that I am trying to access, and I wanted to know the name, only the first key. So I am actually passing the first key to that dictionary, and that it should tell me the content of that key. And I printed in the second one, I wanted to know the age, so I passed the key age to the person, so it actually prints John and age 30. So it goes, let's run this print and see how it actually works. So we created the dictionary, and then we access the dictionary, and it's very simple. So it actually follows the same methods that we have used to access, to create, and to access the list which we have seen earlier. If I want to access just individual, I can access individual regardless. I just need to know the coordinates. And in this case, what we have done, we used the key as the coordinates of the components we want to access. Now, if I have a coordinate that has multivariables, then I need to access it by giving the row number or the key in this case, and then I will put the index of the component in that key that I am trying to access. So let's see how we can actually do some more manipulation on this dictionary. So if I want to add a new key, which means I started with here 3 keys, and I want to add a new key to this dictionary, all I have to do is to actually come down, and I want to say that this, I call the dictionary, then I will actually say I want to add a new key, and I enter the key name, and I will say this is equal to engineering, so engineer. So I am actually entering a new key which is called engineer, and then I want to print this dictionary. So if you look, when I actually print it, I have the key which is occupation, and then the content assigned to this key is engineer. So it's very simple to add component to my dictionary after it has been created. So Python is simple while it's powerful to use. Therefore, you need to remember that. It's logical. To do that in C language probably, or in Java, it will take you a lot more than you can, to actually create the code and to get it to work. You will need to do a lot more than just one single line of addition, and then one, and then viewing it is so easy. Let's look at dictionaries that contain different types. Just a minute ago, I said that we can actually create dictionary that contains different data types. We saw with strings and integers, and in here I'm adding some Boolean data type. And I said that we have a student dictionary, and in there I have the name as a key, and the name is Alice, and age, and I said is 25, and the grades for this Alice are 90, 85, and 92. And I put there is honor student, and I assign to that true. Okay. Now, if I try to access, I've created here. Now, if I try to access, it's exactly the same. What I did, I wanted to print the name. Then I will call this dictionary, and I will pass to it the key that I want to print the content for. And I wanted the name. So when I execute this statement, it should give me a list because it will give me whatever is assigned to name. And I did the same with grades, and I wanted to know the grades, so it will give me whatever grades are assigned to that key. And can you see, it's not just one value, it's a list assigned to this grade. Therefore, it will actually print the full list for me. And then I wanted to see if it's an honor student, and it's assigned to it honor student. Now, if the marks were much lower than this, then we would have assigned false to this key and would have been not an honor student, because you will say is honor student and it will come false rather than true. Okay, so let's execute and run these statements and see. And as you can see, the first statement we called the dictionary student, and I wanted to know the name at that key, what's assigned to that name, and it's Alice. And the grades, as you can see now, is showing all grades which are assigned as a list. So if we had 5 or 6 different grades rather than 3, then it will show all the lists with containing 4 or 5 grades. And then the last one, it actually is true, is honor student, yes. So it will give me true for that assignment, because we have true assigned to this key, which is honor student. Now, nested dictionary. We've seen how we create nested lists earlier, and now we can actually create nested dictionaries in the same way. The first dictionary, or the original dictionary that we have, is actually this dictionary, starting at this curly bracket here and ending there. And then I have a key, and it's assigned to it a string, and then a city assigned to it a string, and then contact, and I have created a nested dictionary there. And in that nested dictionary, I have actually 2 keys, email and phone. And email is assigned this text which says example@example.com, and then on phone I have actually assigned the set of digits to it. Now, if I run this, it should create this dictionary, and then I wanted to access some components within that dictionary. So I call the dictionary itself address, then I will pass to it the key, and in here it actually will reply to me the street, and it's this text, all of it. So it says 123 Main Street. And if I wanted to actually access the contact, but notice that the contact is nested, i.e. there is 2 keys there, and I wanted to access one of these keys, not both of them. So I said phone. I am only interested in phone, so if I run this, it should actually give me the phone. Now if I change this and I say I want the email and run this, it should give me the email. And as you can see, it actually runs quite nicely, and it follows the same logic as we did before, because we can say that the email was index 0 and the phone was index 1, and we just enter that index here. But in dictionary, we're not using index, we are using keys. Okay, so we actually access it by keys. Okay, so if I actually iterate through key values, then I just need to for keys values in person item, and I want to use this for loop, and I want it to go item by item within the dictionary. So what does it do? I am actually calling person item, and I have values which I want to see. It actually goes in the first item is name, so it will go to the first key and it will give me what's assigned to the first key. Then it will increment to the next key, and the next key is age, and it should give me, because that's what I want. I want to print the key, because I use the format print, and it will give me key colon, and then it will give me the value assigned to the key. And that's what it's doing. The first element in this is which is person, and person was created here. If you remember, this is person dictionary. Okay, so we are calling this person dictionary, and we are iterating through it. So items function, and I will pass to it item by item. It will actually select it, and I want to print key 1 or key 0, which is the first key in there, and it will give me the value assigned to it. So it will give me name, which is this key here, and it will give me the value assigned to it. Then it will go to the second key, and it's age, and it will give me the value assigned to it, and then it will give me city and the value assigned to it, and then it will give me the occupation, and it will be the value assigned to it. So this is how I can use for loops to access dictionaries. Exactly the same as we did with the list, and it's very simple, easy to understand, no complication there. And if you have more complicated dictionaries and you try to access and you have problems with it, please write me in the comments or send me an email. So this is how we do it. Now let's see how we create tuples. And if you remember, I told you at the beginning that tuples are lists, but they are immutable, which means you cannot change components within the actual tuple itself. While in the regular list, we were able to change the components. So let's see. To create a tuple, the first difference is look at the brackets. When we created list earlier, we used square bracket. Here we are using parentheses, and you can see the actual content is exactly the same. You can put the data type, and then you can separate them with commas as we did. So I created in this cell the actual tuple, which is assigned to T, and then I wanted to see what's actually within T. So if I run this one here, it tells me that it's actually a tuple because I can see the parentheses, and it will give me the content. Then if I want to access just individual component, then it should actually give me the content at that individual index within the tuple. So if I run this, it actually gives me one. Now, I want here to change this one into a different value, which is man. Okay, so I want to assign this text into this location within tuple. So if I run this, it actually says to me, you got an error. Tuple objects does not support item assignments. You have to be clear and you have to understand the message. The message says you cannot change the content of tuples. Okay, so this is not the same as we did with the list. Before the list, it was simple. We call the index and we assign a new value to it, and we showed it earlier in the previous or just earlier in the last video, and at the top of this before at the beginning of this video itself. Now let's see. I have a matrix here, and I have created these matrix, which is a nested list, and I looked at the content of the location, which is at location 0, and it goes and prints for me this the content. Now, if I want to change a component within this, which is at row 0, and I want component 1, if I want to see it, it will give me this one here. Okay. Now, if I let me run this to execute, and then I run this to execute, and I run this to execute to show you that it's actually. Now I want to change, and this is not a tulip. This is a regular nested list. If I want to change this, look, I access the row, the component in that row, and I assign the value to it. If I run this, it should run because this is a nested list. It's not a tulip. And if I now print my matrix, you can see that it actually changed. It has the value new. So this is just to show you that when we are changing the components in a list, it can be changed. Now in the tulip here we couldn't change it. Tuples, it's immutable and you cannot change the content of that tuple because it's not changeable. Okay, you cannot assign new objects to a tuple. So this is what it is. Now let's create a new tuple, and in this case we call it fruits. And as you can see, I only assigned in this first tuple which we created here, I assigned integers. In this new tuple, what I have done, I have assigned text. So if I create this and I try to print it, it should work. Now notice that I entered text, comma, text, comma, so I separated them. Now I can also say this is a nested tuple because of the way I'm going to actually access it later on, because I want to look at index 0 and then I want to look at individual characters. Then I will start accessing, I would access the nested list as we did earlier. So now we created, we printed, this is what we get, which is the tuple itself, which contain these text values. Now I want to access this tuple, and I only want to see what's actually stored at index 0, and that's index 0 there, index 1 and index 2. So if I access index 0, it should actually tell me what's stored there, which is apple. And if I access index 1, it should tell me that it's banana. So if I run this, then it should give me apple and banana. Now if I want a tuple with different data types, then I can actually create it with different data types, because as you can see here, I have text, integer, and I have boolean, and then I have float. So to create this is very simple, as we did before. It's the curly brackets that actually distinguish it from a regular list. So creating that and running it, it should give me the tuple. Now I have another nested list, which is nested tuple, and then I have, can you see, this is the termination and this is the opening of the list, and in there I have a list also sitting at the first component, and another list, not list, tuple sitting at the next index 0 and index 1. And now I have a tuple inside a tuple. Okay, so we call that a nested tuple. Once you create it, it actually comes and you run this, it will give us the result of the nested tuple. As you can see, it's actually gave and printed that for us, as you can see. Now I can also create another tuple which actually contain coordinates 4 and 5 separated by this value, and then I can assign x to 4 and y to 5, and then I can go and print these coordinates. So if I run this, it actually goes and give me that x coordinate is 4 and y coordinate is 5. And please notice here that the assignment is very simple. I'm just saying that x comma y, and what I am actually making it equal to this tuple, and that means the first component in that tuple is assigned to x and the second component is assigned to y. Now this command is very powerful because later on when we come to create some machine learning, we're actually going to train the models using data, and we will be able to assign part of that data to a variable and the other part to another variable. So we will be using this quite a lot. So this is a very powerful statement, and understanding it is not that difficult. So again, we have created a tuple called num, and I assigned some variables to it, and then I want to use a function called len to check how many components do we actually have in this tuple, because the function len is a function that we are going to use a lot in for loops, and actually detecting the end of our file, how many items, how many samples we have in the data, everything. So if I said for len n, and I will give it the tuple number, that means I am actually setting the conditions. That means it's actually going to stop the for loop at that end when we reach the end of that length, because what it does, it actually goes and check, this is 1, this is 2, 3, 4, and it will keep going. It will not care about the content len. It will actually tells you how many indexes it actually found, okay? Because when we print this, you will see this is 0, 1, 2, 3, 4, 5, 6, 7. So that means these are the indexes. But what did it do? It actually counted 1, 2, 3, 4, 5, 6, 7, 8. So it will give us 8 as the number of tuple of components in that tuple. So it doesn't give us 7, which is the last index. It will give us the number of tuples in that, the number of component in that tuple. So let's see, create, and then we apply the function len on this tuple, and it should come back to us with the length, okay, which is what we are trying to calculate here. Now if I run this, it actually gives me. So if I assign another component, let's say 21, and if I run this, it should give me 9, and so on. So it will actually keep whatever the values there. It gives me the number of these values that are actually there. Now this is just a reminder. You remember how we created a set, okay? We just created a set using a dictionary, or we can actually add to this dictionary, and we can create two-dimensional set by creating set1 and set2, and then I can iterate and carry out operation, union, intersection, and the difference between them. Let's see this simple one here. We've seen it many times before. Therefore, I'm calling this list which we have created, and I'm actually removing and adding, and we looked at it earlier in the code. Now let's look at this one here. I created two sets, and the two sets are actually 1 to 4 and 3, 4, 5, and 6, and I have common component which are 3 and 4 in set 1, and I have it 3 and 4 in set 2. So these are the common components between the two. So if I want to execute the function union, then I would actually go and check what's not repeated, and these are the ones which will be assigned to the union set. So it will actually include 3 once, not twice, even though it's here and here, because a union is bringing the component in set 1 and adding it and joining them with set 2, okay? But if there is a repetition, it will not repeat. It will just use unique items, okay? So that's what the first one will do. The second will look at the intersection between the two. And in here, it will see what are the common components in both sets, and it will actually give me that. So it will actually look at the union, which is between the two, which is a common component between the two. And the third one, it will give you the difference. So what are the difference between set 2, in this case we are looking at set 2, and what are the differences in this case, and I pass set 1 and I pass set2 to the function. I called difference function on set1, and I passed to it set2. It will actually say what are the differences between this one, and it will actually go and return the difference between set1 and set2. Just looking at set1 is actually 1 and 2. So it actually gave me the difference, because we have 3 and 4 in set2, and we have 3 and 4 in set1, plus 1 and 2. So it just tells me the difference between them. So it actually gives me this unique items which are between set1 and set2 again. So if I run this, it should actually works nicely. Okay, now if I change this, where I'm actually passing set2 and I'm calling to it set1, it should actually give me 5 and 6. So if I run this, set2, I need to actually do, I changed the wrong one. So it's here, I'm actually looking at set1, and this is set2. And if I run it now, it should actually give me 5 and 6, the difference between them. So I can play with the logic here, and I should be able to see the differences. Now, checking number in the list, we can actually look at this by creating. We are actually printing is apple in fruit list, and I just called the key apple, and I looked at the fruit list which I have actually created here, and what do I have? I have kiwi, grape, and orange, and I'm looking for apple. So I passed this key, and is it actually in there? And I'm using a boolean check. So it's not there. What does it say? It will say it's not there. And what does that mean? It's false. Now, if I ask for grape, and if I come and change this to a grape, and if I run this, it should actually give me true. So it's actually checking for grape now, and it actually finds grape. So if I put this back to apple, and I run it again, it should actually tells me false, because it's not in that set. So it's not actually there in that dictionary.